Hello, welcome to RCC's Math Tape 082, Graphing Linear Equations. As on the preceding tape, you will need to have graph paper available as you work through this material. You can obtain it from a place where school supplies are sold, or you can make your own with the graph stamps that are available in the math lab. As we read the graphs, you'll have to be especially careful to count up how many spaces are used to get to each point. So you'll have to pay extra close attention on this particular tape. Throughout the tape, as always, mark any places you don't understand so that you can ask for help when you go to the lab. Also, if you miss any of the exercises I give you, be sure to mark those as well so that you can ask the lab instructors or the tutors to help you when you go to the lab. Now let's begin. We have one objective on this unit, but it has 4 parts. Graph linear equations of the form y equals mx plus b, ax plus by equals c, y equals b, x equals a. So we'll be looking at linear equations in 4 forms. Y equals mx plus b, ax plus by equals c, y equals b, and x equals a. Let's begin with a definition. The graph of an equation in 2 variables is a graph of the ordered pair solutions of the equation. The graph of an equation in 2 variables is a graph of the ordered pair solutions of the equation. Since we have 2 variables in our equation, each solution is an ordered pair. The graph of an equation in 2 variables is a graph of the ordered pair solutions of the equation. Let's look at an example. We'll begin with the graph of y equals 3x subtract 4. Graph y equals 3x subtract 4. Notice that we have y by itself on one side of the equation, and so the form is ideal for making our table of values. We will choose values of x that are easy to work with. The numbers I have chosen are -2, -1, 0, 1, and 2. So the x values I have chosen are the integers beginning with -2 and counting straight up to 2. -2, -1, 0, 1, and 2. These are the x values that I have chosen. Remember that to find the ordered pair solutions for an equation which has y by itself, we simply substitute the x number that is chosen into the formula and come up with the y value. And so let's do these one by one. We begin with -2, so that means we will replace x in our equation with -2, and that gives us y equals 3 times -2 subtract 4. Y equals 3 times -2 subtract 4. Well, 3 times -2 is -6. -6 subtract 4 is -6 add -4, which is -10. And so our first ordered pair is -2, -10. Now if x is -1, we substitute -1 in place of x, and we get y equals 3 times -1 subtract 4. 3 times -1 is -3. -3 subtract 4 is -3 add -4, which is -7. And so the ordered pair is -1, -7. Now we get to our very favorite number, the number that makes things as easy as they can be. 0 for x, We substitute 0 in the original equation in place of x, and so we get y equals 3 times 0 subtract 4. 3 times 0 is 0. 0 subtract 4 is negative 4. And so our ordered pair is 0, negative 4. Now we use 1 for x. Substitute 1 in place of x in our equation, and we get y equals 3 times 1 subtract 4. Y equals 3 times 1 subtract 4. 3 times 1 is 3. 3 subtract 4 is negative 1. So y is negative 1, and our ordered pair is 1, negative 1. Then the last number I've chosen is 2. We substitute 2 in place of x and get y equals 3 times 2 subtract 4. 3 times 2 is 6. 6 subtract 4 is 2. And so the ordered pair is 2, 2. By substituting the x numbers that we have chosen into the equation, we've come up with 1, 2, 3, 4, 5 ordered pair solutions. Let's put all of these ordered pair solutions on the graph. I've drawn a graph grid, and let's see if I can get this on the screen. It's hard to get everything I want on the screen with the number 082 to tell you which tape, and the ordered pairs and the graph. But I believe we can get just about what we want.